All right, we're looking at more with linear equations. So, first thing, what is a linear equation? Have you guys been working with them? Yes, you do.
Wait, I know this.
I probably know it.
Pick it apart. If you have an equation, what do you have?
Numbers and
X, Y.
X, Y. And if it's an equation, what sign do you have in there?
equals.
An equal sign. And when you draw it on paper, what does it look like?
A line.
It looks like a line. So, a linear equation is an equation in which x appears in the first power and the data creates a line.
Is that a snake?
So we've been looking at linear equations for quite a while now. So this isn't really new to you. All right, examples of linear equations. Y equals 4/3 x.
Doesn't that have to be like a little plus thing?
Okay. Plus 0. Three x plus 4y equals 2.
It's fine.
4x equals y plus 3. All right, examples of equations that are not linear. So, by definition, an equation in which x appears in the first power. And we've looked at powers just a little bit in our classroom, but you've looked at it before. Power means the what? Something's raised to a power. It's the same thing as
I forgot the name.
It times itself.
times itself, but we have a word for the power.
Got it.
Starts with an E. Exponent. So, if you notice, the x is just x, which means that it's in the first power. So, we could have an equation that looks like this. Y equals 4x squared. This means that x is not in the first power, it's in the second power. It has an exponent of 2. And if you were to graph it, it looks like this. Y equals 4x squared. And if we graph it, that's what it looks like. All right, another example. Y equals 3 divided by x. And the reason that this is not x to the first power is if you were to bring the x up from the denominator, it's represented by x to the negative 1. And you guys will learn that a little bit more next year. That graph looks like this. So it curves around in the two different quadrants. So it looks like this. I'm just showing you examples of things that are not linear.
Oh.
Okay?
So we don't have to do that?
You don't have to work with these. You just have to understand that they're not linear. So when you look at the picture, they're not linear because they're not creating straight lines, right?
Yeah.
Right. And they're raised to powers other than 1. So another example, y equals x cubed.
Oh, geez.
In this one, y equals x cubed, when you graph it,
Oh.
Bad.
looks like that. So those are examples of things that are not linear. All right. So for 1, determine if the following are linear equations. So first one, y equals 2x minus 8.
Yeah.
So think about, we've graphed this, right?
It
So
is
it is a linear equation. 2x squared minus 4 equals 9. Would that be linear or not?
No.
Why not?
Because
has an
it's
exponent.
an
Power.
Correct. No. C. 3 times x times y equals 4. Yes or no?
Yeah.
I have no idea.
What do you think? Do we normally see x and y multiplied together?
No.
We normally see x and y
Separate.
separated, either addition or subtraction. So no, it's not. And if you've got y by itself, it would look like this. You're dividing both sides by 3 and by x to get y by itself. So you would have y equals 4 divided by 3x. And if the x is in the denominator, that's to the negative 1 power. So this would not be a linear equation.
Crazy.
All right.
Crazy.
The other thing that we're looking at is another form to put our equation into. The first form that we looked at was called what? Slope intercept. Second one was point slope. Today we're looking at what's called standard form. Standard form looks like this. AX plus BY equals C. With numbers in it, it looks like example number 2 up here. 3x plus 4y equals 2. We use standard form to graph occasionally. In this class, we just use slope-intercept form primarily to graph. Next year, when you get into Ag 2, you'll use this form to graph lines quickly. So what we're doing with standard form today is we're just moving the equations around. We have had equations where we've tried to get y by itself, and today we're looking at equations to get it in this form. So you've done this process, but you've not necessarily had it look like this before. So, example 2, write the following equations in standard form. So you want the x term and its coefficient to come first, and then the y term and its coefficient to be second. And then on the other side of the equal sign, you want the constant, or that number that's all by itself. So what we're doing with these is we're just rearranging the equations so that they are in this order. The x term first plus the y term equals the constant. So on A, what do we need to move? The 1/2 x. So we're going to add 1/2 x to both sides. So on the left, we have 1/2 x plus y, and on the right hand side we have equals 3. Now, the other issue with this is that we don't want to have a fraction next to the x. We want to have a whole number. So what could we multiply this by to get rid of that fraction?
Reciprocal.
The reciprocal, which is
2 over 1.
2 over 1, which is the same as
2.
So we're going to multiply everything by 2.
You don't do it.
we're going to distribute, but we want everything to be multiplied by 2. So 1/2 of 2 is what? 1, so that gives us 1x, or you can just write x, plus 2 times y is 2y, and that equals 6. So we have our equation in standard form. 1x plus 2y equals 6. B. We have 3y minus 4x minus 8, and this equals 0. So we're supposed to have the 2 terms on the left, the constant on the right. So what do we need to move? The 8. So we're going to add 8 to both sides. So on the left I have,
3y plus 4x.
and that equals 8. Now, which term is supposed to be first? The x. So I'm just going to flip-flop the positions of the 3y and the 4x. Now, you need to make sure that you take signs with the proper term. So this 4x is actually negative, so you need to bring the negative sign with it, negative 4x plus 3y equals 8. C, we have y minus 8 equals 3x. What do you want to move?
Y.
The y? The x? All right, if we subtract 3x from both sides, what do we have on the left? What do we have on the left-hand side? What else?
Negative 8.
Yep. And what's on the right-hand side? 0. So I have negative 3x plus y equals 8. All right, so now we need to determine if the following are linear equations. So we've looked at tables of data before. What has to be true about the data in the tables in order for it to be a linear equation?
It can't be a power thing.
Can't be a power
Power
thing.
other than 1.
Okay, but think about the past couple of weeks when we've looked at data in tables. What are we looking for in the table?
Slope? Oh, no, it's a 0.
Like the relationship.
That there's a relationship, right? That there's a slope. We want to see a pattern, right? So do you see a pattern occurring in the x column? Yes. What do you notice happening in the x column? It's changing by what? 1. And the y column, do you notice a pattern?
Yes.
Changing by 1. All right, so if there's a pattern occurring in the table, is it going to give us a linear equation? If you have a pattern occurring in the table, is it going to give us a linear equation? Is it going to give us a straight line? Yes. You can graph it to double check. You have 0 and negative 2, 1, negative 1, 2 and 0, 3 and 1. So is this going to give us a linear equation? Yes. So look at the table, see if there's a pattern occurring, or graph it. Either way, you can determine whether or not it's a linear equation. All right, 3b. Linear equation or not?
Whoa. Yeah.
Do you have a straight line?
Yeah.
Okay, so
It's linear.
it's linear.
How? Oh, that. I was looking at.
Yeah, I looked at C.
Oh, okay.
Oh, yeah. So
All right, so C, linear or not?
No. No.
Why?
Because it has exponent.
As the exponent.
Nope.
All right, 1a. Write the following equations in standard form. So what do you need to do?
You need
2x.
It's the same thing.
It's a standard.
So what do I have now?
2x plus y equals 3.
Yep. All right, B. 3x minus 9 equals, or minus 2y equals 0. Add 9. So what do I have?
3x minus 2y equals
Okay. 2a. Do I have a pattern occurring on the x column?
9.
Yes.
What's it doing?
One.
What about the y's?
No.
From 4 to 8, what does it do?
Goes up by 4.
And 8 to negative 4?
Going
Down
down
by
8.
12.
Negative 12. And then negative,
Crazy.
yeah, it is crazy.
It is crazy.
Okay.
It's pretty crazy, isn't it?
You can double check this. If you're thinking that your math is off, you can double check this by graphing it. We have 0, 1, 2, 3, 4. You have 1 and 8, which is up here. 2 and negative 4.
Yeah, that's not.
Crazy.
So crazy.
So no, it's not linear. B,
No.
linear equation.
No.
Why?
Because it's curving.
It's
It's
curving.
curving.
C is yes.
That's crazy.
It's crazy. You guys are crazy.
And then go forward towards